Again from Civil Mech Maths Concepts, and I have released 12 videos as of now for engineering mathematics, and it can be useful for IIT Advanced also, and also for CSIR. And in integral calculus, it is the third video which will be dealing with series, sequences, Leibnitz rules, and also the series and sequences, how they are useful for finding the improper integral values for a definite integral where it was not possible for calculating the integral with elementary mathematics or elementary calculus. And welcome everybody, it's Ramchandra again, and we will discuss in detail about the series sequence in the Civil Mech Maths Concepts channel. Welcome everybody. Today we will take up the lecture Integral Calculus 3. Integral Calculus 3. In this, we will continue discussing and extend our discussion from plots and graphs to series and sequence, how the series and sequence will reduce the burden of finding the value of a definite integral which is in an improper form or indeterminate form. This lecture was a little bit delayed, and the last lecture was about some 10 days back. From now on, the lectures will be regular, and for this lecture, a little bit of research and notes had to be prepared. Hence, there was a delay. And also, from this lecture, at the end of the lecture, I will introduce the concept of Leibnitz theorem also. First, how we can relate a series to a definite integral. Please look at this formula. Limit p tends to infinity, sigma p is equal to 1 to n, 1 by n, function of p by n is equal to integral of 0 to 1 function of x dx. In this formula, even though it looks a little bit complicated, let us break it. This function of p by n, this we can relate to function of x. Then is 1 by n, we can relate to d by dx, and sigma we can relate to integral, definite integral 0 to 1, and we can eliminate the limit. The left hand side meaning is limit p tends to infinity, sigma p is equal to 1 to n, 1 by n, function of p by n means a given function, let us say function x, it can be converted into a form of function of p by n, where p is the pth element. We can even replace p with r, that can be rth element in this series. Sigma is sum of. Sigma is nothing but sum of. Adding sum of the pth elements, p starting from 1 to n, up to infinity. Limit p tends to infinity is up to infinity. The function x is nothing but function of p by n. In this form we have to write. Then 1 by n is nothing but dx. And the series, it is an infinite series extending 1 to infinity, p tends to infinity. Pth element, once we know this, and an indefinite integral in the form 0 to 1 function x dx is given, that can be broken into this form, some form, and whichever is the easiest part out of these two. Either we can convert the sum of the series to integral, or integral can be converted into the sum of the series. And in either way, as these both are right hand side is equal to left hand side is equal to right hand side, whichever is given, which is not possible to perform the operation in a traditional manner, or not elementary integrals, or not easily summed up series, then we can use either right hand side or left hand side and we can solve this problem. And to solve these problems, to understand better the problems from series, I have already introduced different types of series in the last class in Integral Calculus 2, where we have developed the graphs and plots. Now, let us recollect some of the series. See, the important series I am here noting down so that this series may regularly or recurrently, frequently come in the examinations. Let it be IIT JEE Advanced, or it can be JEE Mains, or it can be CSIR, or it can be GATE, Engineering Mathematics. The important series are, one is e to the power of x. What is the value of e to the power of x? E to the power of x is equal to 1 plus x by factorial 1 plus x square by factorial 2 plus x cube by factorial 3 and go on. So, in this, let us say I put x as 1. Let us put x is equal to 1. Then e to the power of 1, that is equal to e. What is the value of e in the form of series? 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial and go on. This can be written as 1 by 0 factorial. 1 is nothing but 0 factorial is also 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial. We can write like this, which implies e is equal to sigma 1 by n factorial from 0 to infinity. This can be 1 by 0 factorial plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial plus and so on up to infinity, can be written as e is equal to 0 to infinity 1 by n factorial sum. Sigma is nothing but sum. By seeing the sigma symbol, don't get confused. Sigma is nothing but a sum, ranging from the lower value is from and the upper value is 2. Starting from 0 to infinity. E is equal to 0 to infinity 1 by factorial n. This is the value of E. Now, are there any other values in calculus for calculating E? Let us explore. Another formula for E is equal to, it may not be from integral calculus or series. It is from limits. E is equal to limit. I am putting everything in a concise manner at a particular place, single place, so that once you see E, then you can get every information here. N tends to limit, n tends to infinity. 1 plus 1 by n to the power of n. This is another value, E value. And another related to E is 1 by E is equal to limit n tends to infinity factorial n by n to the power of n whole to the power of 1 by n. Please remember these values. And how you get them, how you get this series. At the end of the lecture, I will explain you. You need not by heart. Try to just have an idea. Then I will derive this series and I will apply them in the integration, definite integrals, and we will see that how definite integrals can be easily found out. Even improper definite integrals we can easily solve with the help of the series. Next. Around some 11, 12 series are there, which I feel very important, and you are required to remember them. Or you are required to derive them. I'll tell the procedure also. You derive them. Try to remember them. If you don't remember also, try to remember the procedure how to derive them in the examination. It takes few seconds only to derive this formula. Next is 1 by 1 minus x, that is equal to 1 minus x to the power of minus 1. This is 1 plus x square plus x cube up to infinity, provided x, absolute x, is less than 1. For absolute x less than 6. 1 by 1 plus x. 1 minus x plus x square minus x cube plus so on. This is 1 by 1 plus x. It has a radius of convergence as 1. This value converges to 1. Then, next series from complex analysis. E to the power of x we have written. Let x be I theta. Let it be e to the power of I theta. What it will be then? 1 plus I theta by 1 factorial plus I theta whole square by 2 factorial plus I theta whole cube by 3 factorial plus and so on. I is nothing but where I square is equal to minus 1. This will be 1 plus I theta by 1 factorial minus theta square by 2 factorial minus I theta cube by 3 factorial plus theta to the power of 4 by 4 factorial and so on. This will be 1 minus theta square by factorial 2 plus theta to the power of 4 by factorial 4 so on plus I into, we'll separate the real numbers and imaginary numbers. Factors of I. Factors of I are theta by 1 factorial minus theta cube by 3 factorial plus theta to the power of 5 by 5 factorial and so on. This is nothing but from complex numbers cos theta plus I sin theta. By comparing the real, equating the real numbers and complex numbers on either side, left hand side and right hand side, we'll get cos theta is equal to 1 minus theta square by factorial 2 plus theta to the power of 4 by factorial 4 and so on. Sin theta is equal to theta minus theta cube by factorial 3 plus theta to the power of 5 by factorial 5 and so on. Instead of theta, you can even say that next equation I can say 8 sin x is equal to x minus x cube by factorial 3 plus x to the power of 5 by factorial 5 and so on. Cos x is equal to 1 minus x square by factorial 2 plus x to the power of 4 by factorial 4 and so on. Then what will be tan x? Can we just divide one series by another series? Tan x is equal to sin x by cos x. Or is there any other procedure? Just see the magic. Tan x is equal to sin x by cos x. That is equal to x minus x cube by factorial 3 plus x to the power of 5 by factorial 5 and so on, whole divided by 1 minus x square by factorial 2 plus x to the power of 4 by factorial 4 and so on. This is tan x. Can we divide the infinite series by another infinite series? It's not possible. Very difficult. There is a procedure for it to write the series. That's what I have told in the beginning. That I will tell at the end of this lecture how to write the series. And from then writing the series, we will go to the integrals, definite integrals, improper integrals. Then we will go to Leibnitz rule. Now, sin x by cos x from the above series, it is like this. This is equal to x plus x cube by 3 plus 2x to the power of 4 by 15 plus and so on. There is one series called Taylor series and another series called Maclaurin series. From Taylor series and Maclaurin series, for any function, it can be written in the form of a series. Tan x, let us say it's not tan theta, it is tan x. Tan x, we can find out these values from the Maclaurin series or Taylor series, and we can equate that this particular series so and so divided by this particular series so and so is equal to this series. A question on this can be framed in such a way that by putting x is equal to 1, a question can be asked 1 minus 1 by factorial 3 plus 1 by factorial 5 and so on divided by 1 minus 1 by factorial 2 plus 1 by factorial 4 is equal to what? That is tan 1. That can be asked in the form of series also. 1 plus 1 by 3 plus 2 by 15. We are making our own GET questions and IIT advanced questions. We should think in those lines. For example, let us say from this only, we'll derive one question. For example, what is the value of 1 minus 1 by factorial 3 plus 1 by factorial 5 and so on up to infinity divided by 1 minus 1 by factorial 2 plus 1 by factorial 4 so on is equal to what? The alternatives also we can write like this. A, sin 1, B, cos 1, C, cosecant 1, D, tan 1, where the angle is in radians. What do you say from this? It's nothing but tan 1. Because x is equal to 1, I have put in the series. Answer is tan 1. Similarly, they can ask what is the value of this. Alternatives can be given this way also. 1 plus 1 by 3 plus 2 by 15 and so on. B. 1 minus 1 by 3 plus 2 by 15 minus C. 1 plus 1 by 3 minus 2 by 15 and so on. D. 1 minus 1 by 3 minus 2 by 15 plus so on. What is the correct answer? Correct answer is this one. So, either of this way, a series divided by another series, we got a fixed value, either in the tan 1 or in the other series form. This is the beauty of the series. And next, we'll go to another series. Now secant x. These are all what I am giving you is some important series. The series can be of any type. Series can be anything. That we can definitely look into once we go into the development of the series with the help of the Taylor polynomial. Secant x is equal to 1 plus x square by 2 plus 5 by 24 x to the power of 4 plus 61 by 720 x to the power of 6 plus 6. Now, let's go for another one. Log or ln 1 plus x. What is the value of ln n plus 1 plus x? This is equal to x minus x square by 2 plus x cube by 3 minus another ln 1 minus x minus x plus x square by 2 plus x cube by 3 plus so and so on. Now, what will be the value of ln 1 plus x by 1 minus x? This value is nothing but ln 1 plus x minus ln 1 minus x. That is equal to x minus x square by 2 plus x cube by 3 so on minus of minus x square by 2 minus x cube by 3 and so on. This is equal to x plus x plus x cube by 3 into 2 plus x to the power of 5 by 5 into 2 plus so on. This plus x square by 2 minus x square by 2, they get cancelled. Then this value will be 2 into x plus x cube by 3 plus x to the power of 5 by 5 and so on. This is the value of ln 1 plus x by 1 minus x. These are some important formulae which series whose values you are required to know and you are required to derive them from the basic principles. Once you derive from the basic principles of Taylor series or Taylor polynomial, then these will imprint in your brain and you will never forget them. And in case of doubt, you can go back to your Taylor polynomial derivation and you can find out the series. Now, for general series, let me say, can you find out some values? Can you find out ln 2? ln 1 plus x is equal to x minus x square by 2 plus x cube by 3 so on. ln 2 is equal to ln 1 plus 1 where x is equal to 1. 1 minus 1 by 2 plus 1 by 3 and so on. The same value ln 2 or log 2 can be written as 1 by n plus 1 plus 1 by n plus 2 up to 1 by 2n. You just think over why it is so. Then you can even think ln 3 is equal to or log 3 is equal to 1 by n plus 1 1 by 3n. Can we generalize? Homework question. Can we generalize ln p is equal to 1 by n plus 1, 1 by n plus 2 up to 1 by pn. These series are very, very important. I am giving stress on them. In the last class also I have explained the importance of the series, and these are all very important because in case of dichotomy where you are unable to understand the problem, the series will come for your rescue in the competitive examinations. take them very seriously and understand them, understand the meaning of it, the meaning behind this series, and use them in your day-to-day working. For example, now let us say, now you understood the series. Now we get a feeling that remembering all these series and a different series is given in the examination, what to do? How we can develop them? How different series can be developed in a simple and practical manner without by hurting them? I'll tell now. Now we'll go for Taylor polynomial and try to understand how to develop a series. And afterwards we'll solve one, we'll develop a system, or we'll develop a solution for the IIT Advanced mathematics question. It may be from IIT Advanced. We cannot deny that type of question may not be given in GATE, because the standard of the question is almost equal to GATE engineering mathematics. Indefinite integrals or limits, whatever we call. The limit of some series is nothing but a definite integral. So that we can't say that limits are different and definite integrals are different and series is different. Everything is linked to each other. Now, what is Taylor series? What is Taylor polynomial? Taylor polynomial. Let us discuss something on it. Let us say there is some function is there. There is some function. I told you series can be expressed. A function can be expressed in the form of a series. That can be a polynomial. A function is there, that we'll call it as a function x. Function in x. At x is equal to a, or x minus a is equal to 0. The above function can be written in a polynomial form, Pnx is equal to, at x is equal to a, it can be function a plus, in a series form, function dash a into x minus a plus function double dash a into x minus a whole square by factorial 2 plus function triple dash a into x minus a whole cube by factorial 3 plus so on. A function fx at x is equal to a can be expressed in a polynomial form like this. For example, a is equal to 0. Put a is equal to 0 in above. What happens? Let us see. Polynomial x can be function 0 plus function dash 0 into x minus 0 plus function double dash 0 into x minus 0 whole square plus function triple dash 0 into x minus 0 whole cube. This is divided by factorial 2. This is divided by factorial 3 plus so on. This is divided by factorial 1. This is the formula. A function x can be expressed in a polynomial form as per Taylor series, where polynomial x is equal to function 0 plus function dash 0 into x minus 0 by factorial 1 plus function double dash 0 into x minus 0 whole square by factorial 2 plus function triple dash 0 into x minus 0 whole cube by factorial 3 plus so on, so on, so on. This can be written as f0 plus f dash 0 into x by factorial 1 plus f double dash 0 into x square by factorial 2 plus f triple dash 0 into x cube by factorial 3 plus so on. Now, this is function x. Now let us take, this is function x. Now, we have written many, almost 15, 16 series. Let us take one series. Let us take one series, one function, to express it in the series form. Let us say function x is equal to sin x. Then what will be the value of function dash x? Cos x. Function double dash x minus sin x. Function triple dash x minus cos x, and go on. Now how the series function x can be written in the form of a polynomial? Function 0 plus function dash 0 into x by factorial 1 plus function double dash 0 into x square by factorial 2 plus function triple dash 0 into x cube by factorial 3 plus so on. What is the value of function 0? Function 0 is equal to sin 0, that is equal to 0. Function dash 0, that is equal to cos 0, that is equal to 1. Function double dash 0, that is equal to minus sin 0, that is equal to 0. Then function triple dash 0 is equal to minus cos 0, that is equal to minus 1, and go on. When you replace these values in the main polynomial equation, sin x will be function 0 is 0 plus function dash 0 is 1 into x 1 factorial plus function double dash 0 is 0, 0 into x square by factorial 2 plus function triple dash 0 is minus 1, minus 1 into x cube by factorial 3 plus 4, which implies sin x is equal to x minus x cube by factorial 3 plus x to the power of 5 by factorial 5. As you go on doing it, minus. This is nothing but what we have previously expressed few minutes back. It is sin x. Now let us go for e to the power of x. Let us go for e to the power of x. Let function x is equal to e to the power of x. Function dash x is equal to e to the power of x. Function double dash x is equal to e to the power of x. Function triple dash x is equal to e to the power of x. If x is equal to 0, it means function 0 is equal to e to the power of 0, that is 1. Function dash 0 is equal to e to the power of 0 is equal to 1. Function double dash 0 is equal to e to the power of 0 is equal to 1. Function triple dash 0 is equal to e to the power of 0 is equal to 1. And so on. Then e to the power of x in polynomial form will be function 0 plus function dash 0 into x by 1 factorial plus function double dash 0 into x square by 2 factorial plus function triple dash 0 into x cube by factorial 3 and so on. That is equal to function 0 is nothing but 1 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus so on. Therefore, e to the power of x is equal to 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus so on, that is equal to sigma n is equal to 0 to n is equal to infinity. X by n factorial. Plus 1 minus x. This is the value of e to the power of x. E to the power of 1 is equal to integral n is equal sum n is equal to 0 to infinity, that is equal to 1 by factorial n. This is the value of e. This is equal to e. This is the way. Now you understood from the Taylor series how to develop a given series, and for all the 11 series whatever I have given, 11 or 15 series, please try to find out the Taylor polynomial and you try to equate those series values to the Taylor polynomial and develop your own series, so that you will never forget in your examination for solving these questions on series. I told you in the beginning itself, limit n tends to infinity for a value of a function. When it is not a simple function or any other function, we can represent in the form of a series, and the form of a series, sum of the series, can be equated to a integral. This is how definite integral is linked to the Taylor polynomial, then series, sum of the series, and to the limit n tends to infinity or whatever value, to the definite integral. Now let us do one small example. It may be looking like a simple limit problem, but it's not so. Given in IIT Advanced recently, we have to find the value of a. We have to find the value of a question, so that the right hand limit of the function e to the power of ln 1 plus x to the power of 1 by x minus e to the power of minus 1 by x to the power of a has a real value, a real non-zero value. Real non-zero value implies a is equal to how much? This is a very beautiful question. At the face of it, people feel that it's a question from limits and preliminary calculus. It's not so. It's a series problem, very good series problem, and let's try to solve it in seconds. Let us try to solve it in seconds. Let us see. What is ln 1 plus x to the power of 1 by x means? This can be written as e to the power of ln 1 plus x by x. Can we write like this? Yes, we can write like this. Go back to your prelims of e to the power of logarithms ln e to the power of x. Because e to the power of ln x to the power of y is equal to e to the power of y ln x. This is the first step which you should understand. Next, what is the other step? ln 1 plus x, if you think. What is ln 1 plus x? Don't just go by doing your traditional mathematics of finding the integral, derivative, then L'Hospital's rules, all these things you forget. What is ln 1 plus x? ln 1 plus x is equal to, what is its value? I have told you already. X minus x square by 2 plus x cube by 3 minus so and so, so and so. Then what will be the value of ln 1 plus x by x? That will be 1 minus x by 2 plus x square by 3 minus minus. Can I write this way? Minus 1 into 1 plus x by 2 minus x square by 3 plus so and so. This is the heart of the problem. Now we understood the heart. Then this left hand side limit will be, left hand side will be limit x tends to 0 plus right hand side limit e to the power of minus 1 into 1 plus x by 2 minus x square by 3 plus so and so minus e to the power of minus 1 by x to the power of a. Then this will be e to the power of minus 1 into 1 will be e to the power of minus 1. Understood? Then this e to the power of minus 1 can be taken as common, and this will be e to the power of x by 2 minus x square by 3 plus so and so minus 1 whole divided by x to the power of a. You just imagine, we got the series e to the power of so and so. That also we can further break into another series e to the power of x. This whole you can take it as some value, some p, and break it. And this minus 1 e to the power of minus 1 has come. Now, this whole limit should be existing. For the limit to exist, what we have to do? The limit should not be in the indeterminate form. At the same time, the limit should have a real non-zero value. For that, a should be equal to 1. You please think over why a should be equal to 1. I give it as a homework to you. You please think over, and we'll do it, this problem in detail. Or if you could not understand, you please comment. Then I will explain you in the next class. I will explain you in the next class why a should be equal to 1. This is what is the heart. What is the heart? The series of ln 1 plus x. To know about that, and then dividing that series by x, and then simplifying that limit, whatever that function value is given within the limit, and finding the limit. And ultimately, that is the value, and that's how the problems of series can be applied in our finding the limits, finding the definite integral values, finding the sum of the series. But the core and heart of finding these are not traditional methods of just putting something in the formula and deriving it. You go for the Taylor series, find out the series, and then put the series in the given function and find the limits or a definite integral. You will be able to solve the improper integrals very easily. Now, let us have little insight into a deeper meaning of this series and application of them and questions asked in GATE 2024 on this. Till now, we know that e to the power of x is equal to 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus and so on. Then what will be the value of e to the power of x square? Think over for 10 seconds. Instead of x, the power of e to the e is x square. Then e to the power of x square is equal to 1 plus x square by factorial 1 plus x square whole square by factorial 2 plus x square whole cube by factorial 3 plus so on. Then e to the power of x square is equal to 1 plus x square by 1 factorial plus x to the power of 4 by 2 factorial plus x to the power of 6 by 6 factorial and so on. Then we know cos x is equal to, what is the value of cos x? Just check. What is the value of cos x? Cos x is equal to 1 minus x square by factorial 2 plus x to the power of 4 by factorial 4. 1 minus x square by factorial 2 plus x to the power of 4 by factorial 4 and so on. Then, can you find out what is the value of e to the power of x square plus cos x? That will be 1 plus x square by factorial 1 plus x to the power of 4 by factorial 2 plus x to the power of 6 by factorial 6 plus so on plus cos x is 1 minus x square by factorial 2 plus x to the power of 4 by factorial 4, so on. When you add these two, cos x plus e to the power of x square, what is its value? 2 plus x square into 1 minus 1 by factorial 2 plus x to the power of 4 by, when you take it common, 1 by factorial 2 minus 1 by 1 plus factorial 4 and so on, and similarly for x to the power of 6 also. This is how a series can be expanded. Then if you want to find out the value of, for example, the value of coefficient of x to the power of 4, then the value of coefficient of x to the power of 4 in this cos x plus e to the power of x, cos x plus e to the power of x square, the value of x to the power of 4 coefficient is equal to 1 by factorial 2 plus 1 by factorial 4. 1 by 2 plus 1 by 24. That will be 24, 12 plus 1, 13 by 24. This way we can find out the coefficients of a particular power from the Taylor expansion, Taylor polynomial. Now, I will give you one homework question. It's from GATE 2024. The question is, if function z is equal to cos z plus e to the power of z square, then find the coefficient of z to the power of 5 in the above if expanded through Taylor series. This is a direct question given in GATE 2024, which you can do in seconds by looking at the question itself. You please answer this question. The coefficient of z to the power of 5 is 0. There is no coefficient of x to the power of 5 in this series. Answer is 0. How many seconds it took for you? Not even 10 seconds. You scored a mark. Let it be IIT Advanced Mathematics. Let it be GATE Engineering Mathematics. Once you know the concept, you will be able to answer it without doing any mathematics. By glancing at the question itself, you will get the answer. Understanding the concepts of mathematics is more vital in solving the mathematical questions in competitive examinations like IIT Advanced or JEE Mains, CSIR or GATE examinations, GATE Engineering Mathematics. The conceptual understanding is more important than by hearting the formula. This is what I was telling since from the beginning, and this is what we have been seeing from the first class of mine. And for example, if you want to expand this will be 2 plus x square by 2 plus 13 by 24 x to the power of 4 plus 119 by 720 into x to the power of 6, where the coefficient of x to the power of 5 is 0. This is the answer. It could be done in seconds at a glance when you understand the concept of the Taylor series expansion. Now, let us move forward to a very, very important concept in integral calculus. We have seen L'Hospital's rule in understanding and doing the limits in elementary calculus. Now we will move forward to a little bit higher level understanding in integral calculus. It's not about the L'Hospital's rule. We can say it's a Leibnitz theorem. It's a Leibnitz theorem. I'll just give one small formula for finding the Leibniz, the definition of the Leibniz theorem, and we'll develop it in the next classes follow. It's a very useful rule combining the partial differentiation with definite integrals and many improper integrals can be evaluated by using this theorem. Let us write the theorem. Today we will write only the theorem and we will understand the meaning of it in the next few classes, and we try to apply it along with the series, sequences, definite integrals and improper integrals. I'll end this class with Leibnitz rule. Leibnitz rule or theorem. What it is? If a definite integral from a to b of function xp dx is equal to fp, function of p, then df by dp is equal to integral a to b dou xp by dou p. Please try to understand the physical meaning of it, graphical meaning of it, and try to deliberate from yourself. Till in the next class, I will explain about this Leibniz rule to all of you. It is a very, very useful rule. And with this, I want to conclude today's class. Today we develop different series with the help of Taylor polynomial, and we could link limits to the sum of the series and the sum of the series to the definite integrals, and find out the values of the definite integrals. Going back to the series, simplifying the problems and solving them in few seconds. Second, we have solved one problem from IIT Advanced on the same basics, and we solved another problem from GET 2024 on the same basics. Once you catch the basics and fundamentals, concepts, you can easily solve any type of problem that's being asked in the examinations. Let it be CSIR, let it be IIT JEE, mains or advanced, or let it be UPSC civil services, or let it be GET engineering mathematics examination or any international maths Olympiad examinations. Now, a concept on Leibniz rule is mentioned today, and we will develop this concept as we move forward with the series definite integrals from next class onwards, and after a couple of classes we will go to the differential equations. Best of luck to everybody. It's Ramchandra again from Civil Maths Concepts. If you like my videos, please see all my previous videos. There were 12 videos on engineering mathematics concepts. Please see them, view them, comment them, and if you have any suggestions, please suggest for the improvements, and we will move forward in the next class on this integrals, definite integrals, and move forward afterwards to differential equations. Best of luck to everybody.